Hello and welcome to this demonstration on performing a range test using CEL's MeshConnect development tools. By watching this demo, you will learn how to perform a range test and a packet error rate test. You will also learn how to use the MeshConnect test tool software. Before we get started, in case you're interested in how to get your hands on a MeshConnect development kit for your own RF evaluation in your environment, you can contact your nearest sales representative by visiting CEL's website at cel.com, or you can purchase a development kit today through various authorized CEL distributors. In this demo, we will showcase CEL's MeshConnect EM357 mini modules, the industry's smallest Silicon Labs Ember EM357 Based Modules, with a mini footprint of 23.9 mm by 16.6 mm. The MeshConnect mini modules comes in two flavors: SP0, a low output power solution with a transmit power of 8 dBm and an RF link budget of 108 dB. This module is FCC, IC, and CE certified. SP2 is a high output power solution with a transmit power of 20 dBm and an RF link budget of 123 dB. This module is FCC and IC certified. In the development tools, the mini modules are mounted on a MeshConnect plug-in daughter card or a Silicon Labs Ember module board. These plug-in cards can easily connect to CEL's Universal Evaluation boards and Silicon Labs EM35X breakout boards. Ember Silicon Labs EM35X development kits are now shipping with MeshConnect EM35X mini modules. For more information, visit silabs.com/products/wireless/Zigbee. Lastly, we will show you how to use MeshConnect test tool software for hardware evaluation. This software is available for download at www.cel.com/MeshConnect. Now that we're familiar with the tools, let's get started on this demo. Range test. Push button sequence for range testing between a coordinator and an end node. Here are two MeshConnect evaluation boards. One will be assigned the coordinator and the other the end node. We will turn on the coordinator by sliding the power switch to the middle position. You will see the LED lights cycle. Next, we will press and release SW0 and an LED light will illuminate. This will indicate that a network has been formed properly. Now that we have the coordinator established, we will power on the end node by sliding the power switch to the middle position and allowing the LED lights to cycle again. On the end node, we will press SW1. Once the LED light illuminates, it has found and joined the network. To begin the range test, we will go back to the coordinator board and we will press and release SW1. The range test is running. An LED blink on the coordinator board indicates that a packet has been transmitted. An LED blink on the end node indicates that a packet has been received. You can start or stop a range test by pressing SW1 on the coordinator board. You could also run a range test from the end node board to the coordinator board by pressing SW1 on the end node board. Likewise, an LED blink on the end node indicates that a packet is being transmitted. An LED blink on the coordinator board indicates that a packet is being received. To stop the range test from the end node to the coordinator board, we will press SW1 on the end node board, and the LED lights will stop blinking. Now you know how to run a range test using MeshConnect development tools. Let's power off the board by sliding the power switch back to the off position on each board. This concludes our range test demo portion. Per test. Push button sequence for packet error rate testing between a coordinator and an end node. Here we have two MeshConnect Universal Eval boards with a coordinator on the left and an end node on the right. We will turn on the coordinator by sliding the power switch to the middle position. You will see the LED lights cycle through. Next, press and release SW0 and the LED light will illuminate. The coordinator has now formed a network. Next, we will power on the end node by sliding the power switch to the middle position. Let the LED light cycle through, then press SW1 to join the network. Once the LED light illuminates, it has joined the network. We are now ready to perform a packet error rate test. Now we're going to transmit 100 packets from the coordinator board to the end node. You can start the PER test by pressing SW0 on the coordinator board. 100 packets are now being transmitted by the coordinator and being received by the end node. The LED lights on the coordinator and end node will continue to blink as packets are being transmitted and received. If all 100 packets have been received successfully, LED 3 on the coordinator board will briefly illuminate. If there is an error condition, LED 2 will illuminate. You can also perform a packet error rate test from the end node to the coordinator, simply by pressing SW0 on the end node. Likewise, the end node is now transmitting 100 packets to the coordinator, and the coordinator is receiving the packets, indicated by the blinking LED lights. If all 100 packets have been received successfully, LED 3 will briefly illuminate on the end node. If there is an error condition, LED 2 will illuminate. That concludes the packet error rate test. We have shown you how to run a range test and a PER test. Let's power off the board and show you how to run the MeshConnect test tool software. MeshConnect test tool, RF hardware evaluation software. There are 3 modes of operations when connecting your universal eval board to the MeshConnect test tool software. Mode 1 consists of 1 PC with MeshConnect test tool software and 2 universal boards connected. Mode 2 requires 2 PCs with MeshConnect test tool software and 2 universal boards connected. Mode 3 has 1 PC with MeshConnect test tool software, 1 universal board connected, and 1 universal board not connected. Let's demonstrate the MeshConnect test tool software with Mode 1. 1 PC with MeshConnect test tool software, but instead of using the 2 universal boards connected, we will use 2 Ember breakout boards that are connected. Here I have connected 2 Ember breakout boards via USB port. The one on the left will serve as the coordinator and the one on the right will serve as the end node. Let's power on the coordinator by connecting it to the USB port on the PC. An LED light will illuminate on the Ember breakout board, indicating that power has been established. Now that we powered on the coordinator, let's launch the MeshConnect test tool software. Next, click Auto Detect to detect the hardware. On the Select Mode screen, click Zigbee Mode, then click Submit. Since the board on the left will act as a coordinator, go ahead and use the default settings, then click Submit. The test tool software is now configuring the coordinator as a Zigbee device. After configuration, the MeshConnect test tool software interface will appear. On the upper left hand corner of the interface, you will see the module we are working with, along with the COM port, baud rate, and module type. On the bottom left hand corner of the interface, you will see the MeshConnect radio settings, where you can find the PAN ID, the source ID, RF channel, RF power, and MAC ID. On the bottom right of the interface, you can find the data log and the hyper terminal. On the upper right hand corner, there are several tabs. There is a PER setup tab which runs a packet error rate test. There is also a range tab which I will cover later in this demonstration. There is a low power tab. There is a version tab. Let's click on Get Version for hardware specifics. Here you will see the stack version, the firmware version, the module version, along with the type of board, which is the Ember board. On the ADC tab, you can monitor the temperature of the module by clicking on Get Temperature. There's an external flash tab. Since there's no external flash on this Ember eval board, this section is grayed out. There are some boards that have external flash present. The last tab is a network tab. This will display the coordinator we have powered on earlier. It is sending out a signal and looking for an end node to join its network. Now that we're familiar with the MeshConnect test tool software, let's go ahead and run a range test by clicking on the Range tab. Next, let's power on the end node by connecting it to the PC. You will see the LED light on the end node illuminate, indicating that power has been established. Now that the end node is powered and connected, let's launch the second instance of the MeshConnect test tool software and click Auto Detect. On Select Mode, click on Zigbee Mode, then click Submit. Since we already have the coordinator established, let's select this as an end node and keep the default settings, then select Submit. Now we're configuring this end node as a Zigbee device. Once configured, you will see a second MeshConnect test tool interface appear. On the end node interface, let's copy the source ID to the clipboard by hitting Ctrl+C. Then let's go up to the Range tab, select it. Then let's head over to the interface for the coordinator. Let's paste the source ID under destination address. Set the rate to continuous. Then click on Start Range Transmit button. As you can see on the coordinator module board, a green LED light is flashing, indicating that a packet is being transmitted. On the end node module board, a red LED light is flashing, indicating that packet is being received. You can stop the range test by clicking on the Stop Range Test button. By stopping the range test, you can see that the LED lights stop blinking. Let's run a range test from the coordinator to the end node board by copying the source ID to the clipboard on the coordinator interface and paste it under destination address in the end node interface. Go down to rate and select continuous. Then select Start Range Test. This time around, you can see a green LED light flashing on the end node module board, indicating that a packet is being transmitted. On the coordinator module board, you can see a red flashing LED light, indicating that a packet is being received. You can also run a bidirectional range test. Let's go over to the coordinator interface and select Start Range Test. Now you can see that the coordinator and the end nodes are flashing LED lights. The green LED flashing lights indicate that packets are being transmitted. The red LED lights indicate that packets are being received. This is a bidirectional range test. You can now stop the range test by clicking Stop Range Test on both interfaces of the MeshConnect test tool software. This concludes our demonstration on performing a range test using the CEL's MeshConnect development tools. For more information, visit us at www.cel.com/meshconnect. Thank you for watching.